Uh, Good morning, good afternoon, good evening, my learners and my viewers. Welcome back to Menya School, the channel for education and educational matters only. Well, it is science this morning. It is science and science about experiments. Now, my learners, boys and girls, carrying out experiments and making out observations is key in developing a quite or a multiple of skills and abilities in learners. Um, the knowledge that we acquire in science alone is not enough. We encourage that the learners should become critical thinkers, and this skill of critical thinking is greatly developed by carrying out scientific experiments. So what are features of a science experiment? I had mentioned earlier on in my previous video that in a, a Kenya, a KCP science paper, expect more than 10 questions from scientific experiment that you have done or your primary course. So let's analyze and look at the features of a science experiment. Yes, when carrying out a science experiment, what do we look at? And from there, it is where questions which come on experiment test. It is the features of an experiment that the questions test in a KCPE science paper. Feature number one is, in an experiment, we must have requirements. So what are requirements? Requirements are materials and the tools needed to perform that particular experiment that you want to perform. Feature number two is the procedure. When you have collected the materials, you have brought the tools together. So what are the procedures? What are the steps to follow in order for you to perform that experiment? Feature number three is the control variables. The control variables are, what are the factors that you can keep constant in that experiment in order for you to make the right observation and maybe eventually make the best or the right observation. Feature number four is the setup. The setup is actually the diagram, the arrangement of how our materials are arranged, and then how are those materials going to be arranged, and then represent that information on a diagram, the setup. Feature number five is observation. Boys and girls, I want to tell you that observation is what you see, what you feel, what you hear, and smell. In other words, observation triggers your five senses when you are performing that experiment. What did you see? What did you feel? Seeing, make use of your eyes. What did you feel? Touch, sense of touch. What did you hear? And then what did you smell? Feature number six is explanation. Yes, you have made a particular observation. How do you explain that observation made? Feature number seven is conclusion. Yeah. Yes, the conclusion is that data that derived from the experiment. Yes. How do you conclude from your explanation? Therefore, how would you conclude? Then finally, the last feature is application. How that how is how it can be used in real life situation. I want you to take I want to take you through. I want to pick on one example, on one experiment example. We go through those features, and then later on you come to learn that, oh, kumbe when a question is tested like this on an experiment, kumbe they are testing this feature that we have already discussed. Let's look at an experiment on comparing drainage in different types of soil. Feature number one: what do you require? What are the requirements for that experiment? For example, you may require, not for example, in fact, actually, this is what you require: 3 potholes. Sometimes they can be called collecting jars. You also need funnels. You may require cotton wool, or a piece. If you don't have a piece of cotton wool, you'll have pieces of cloth, an alternative, isn't it? And if you didn't have 3 plastic potholes, the alternative could be collecting jars, and also the funnels. I've already mentioned that. And then 3, you must have the 3 types of soil. That is loam, sand, and clay. And then water, and then scale, and then measuring cylinder, and a stopwatch. So, what are the control variables? What are the factors that must be kept constant in this experiment? In other words, the things that must be constant, in other words, they must be equal and in size, equal in size or amount. So the amount of what to be put on the funnel, on each funnel, must be the same. Must be of the equal amount. The size of the cotton wool that is placed and the nini must be of the same size, isn't it? The amount of each type of soil also must be the same. The duration for each set also must be the same. The size of the funnels also must be the same. What are the things that well, it can either be of equal size or not? So you should just consider that. Now, the collecting jars should necessarily not be the same, because if the collecting jars of different sizes are used, then you can measure that water elsewhere using a measuring cylinder. That can measure the amount of water collected from each setup if the size of the collecting jars are of different size. Then what are the things that must not be the same or equal in size? The things that must not be the same or equal. They must not be the same or equal. The type of soil. Why? You cannot use sand in all the 3 funnels. The type of soil must not be equal. Okay? Because of the size of the soil particles. What is the procedure? What can be the procedure to be followed in this? Procedure number 1 would be you cut the potholes to obtain the funnels and the collecting jars, and put the cotton wool at the neck of each funnel, and then place the funnels on the collecting jars, pour equal amount of each type of soil into the funnel, and finally pour equal amount of water at the end of water into the funnels and that should be done at the same time. Then after that, make the drawing of that setup of those 3 funnels, the collecting jars and all that, isn't it? Then label one of the diagrams. So from that experiment, what is the likely observations? What are the likely observations that you will make from that experiment? One, you will see the first drop of water seen in sand soil. The first drop, you will see it on sand soil. In observation number 2, that you'll see is the amount of water was collected from sand soil, and the least amount of water was collected from clay soil, and an average or medium amount of water was collected from loam soil. 4 observations. I may repeat that. The first drop of water was seen in sand soil. You will see that one. You see what your enemy. Later on, the most amount of water was collected from also sand soil. And the least amount will be collected from clay soil. And an average or medium amount of water was collected from the loam soil. How could you explain that now? Feature number 6. What is the explanation for each of those observations made? Sand soil allows most water to pass through because it has large air spaces. Clay soil allows the least amount of water to pass through because it has small air spaces. Loam soil allows an average amount of water to pass because it has medium-sized particles. So from the explanations above, what conclusions would you make from the above? We can conclude that sand soil has the best drainage. Conclusion number 1. Conclusion number 2, clay soil has the poorest drainage. Conclusion number 3 is loam soil just allows enough water to pass through. 4, the size of air spaces. Kumbe, the size of air spaces affect drainage in soil. What can that experiment now, the last feature, on its application in the above experiment? What can it help us in our day-to-day lives? Or kumbe, loam soil is good for farming as it allows just enough water to pass through it. Sand soil is good for construction. Kumbe, sand soil is good for construction due to what? Due to its large air spaces that can allow it mix with the cement. Oh, and that's why kumbe clay soil and its tiny particles. That's why clay soil is the best for modeling due to the small particles that allow it to make the longest ripples. Thank you for watching. Subscribe to this channel. Share it out to other candidates so that as you face that science paper on Tuesday, you may be able to pass. I wish you the best in your exams and pass high in science. May God bless you. Thank you.